Hello, my name is Gwen Sexton and welcome to my short presentation about using Wireshark for 802.11 frame capture. In this presentation we're using the AirPcap NX tool by Riverbed that is a USB network interface card that will operate at A, B, G and N standards, and you can see from the picture on the slide there are two connectable antennas to this particular interface. This allows us to collect the control and management frames from our 802.11 environment that we're particularly interested in looking at. So before we actually do any work, we've got to ensure that this particular network adapter is plugged in to our system. If you're actually doing this, can I just ask you to take a special care of these devices? They're quite expensive. They're several £100s each, and the connectors that are used to connect the antennas to the AirPcap device are what I would call delicate and ephemeral and would be broken very, very easily. So you need to just be careful when you're actually doing this. I'll just add that AirPcap supports monitor mode operation that allows us to collect information from any wireless network rather than just the wireless network that we're actually connected to. So once we have the AirPcap NX device plugged in, we can start up Wireshark and we should get a screen looking something like what we see on the screen here. This is our Wireshark startup screen. And in order to go further, we have to ensure that we select the interface that we would like to capture on. So we're going to capture on the AirPcap interface, so we need to make sure that's selected. And then to actually commence capture of data, we press this button at the left, which I'm going to call the fin, and that will then start capturing packets from the AirPcap USB interface. Well, before we commence actually collecting any data, we've got to make sure that we select the correct frequency of operation. So to help us do that, we've got to make sure that we have our wireless wireless configuration bar selected, and you can see I've just selected that and selecting a channel, so we're operating on channel 6. This is just for this particular example. You can obviously operate on any channel that you want, but you do need to ensure that you're selecting the actual correct frequency, and you'll only be capturing information on one channel at any one time. It is possible for Wireshark to collect information from multiple channels, but you do need multiple adapters. So under normal circumstances, you'll only have one adapter available. So it's one channel at any one time. That's a small limitation. Now, when we capture data, and if you haven't done this before, one thing you'll notice immediately is the sheer volume of data that Wireshark will capture on a fairly busy network. This poses a few problems. It's just merely the amount of data that we have prevents us from often finding what we want in amongst all of the data itself. And there are some simple tools, very powerful simple tools that allow us to display or collect data in a more appropriate way. So the tools that we're going to talk about right now are filter tools, and there are two classes of filter tools. We have capture filters and display filters, and I'll very briefly describe the difference between capture and display filters. So beginning with the capture filter, these essentially filter data at the time of capture itself. So you can select which packets that you wish to capture. The big downside is that if you don't capture the data, it's lost forever, so you can't later analyze that data. The big upside is that the data capture size is often much smaller than doing a full capture, particularly on a very, very busy network. And so if you imagine that you want to do a capture over a 24-hour period, looking for particular data from a particular source or destination, then you would potentially need a very, very large amount of disk space. So using capture filters can reduce that necessity for huge amounts of storage space. Display filters, well, display filters are probably the more flexible filter of the two. Here with display filters, assuming that you hadn't had a capture filter in place, then you've captured everything that was available on the interface, and the display filter then allows you to sift through that data in quite a clever way to display what you're really interested in. The downside of display filters, particularly if you're running them for the capture for a long period of time, is that you can create some very large files and that they can be unwieldy to handle. Okay, so we're going to have a go at setting up a capture filter, and there are a few ways to do this. You can see a bit of the startup screen that you'll be presented with there, and indeed, we can actually enter a capture filter at this point here where my cursor is. So that's one way we can do it, but I'm not going to do that. So I'm going to actually go into Wireshark without any filters captured, and just start Wireshark there and stop it immediately. And from this screen, we can set up a capture filter a number of ways. We can go to the capture drop-down menu, and rather unintuitively, you don't use the capture filters menu item, but you can select options, or we can just select the options on the toolbar there. So I've just selected that option there, and what we now have to do is to ensure that the right adapter is being selected. So we apply the capture filter to the correct adapter, and it's the AirPcap wireless adapter that we want to use, and then we enter the capture filter in this window at the bottom of your screen there. Now there will be some previously entered capture filters that I can just use rather than type them in slowly. So here is an example where we want to capture only packets or frames that are going to or coming from this device with this particular MAC address. So it's a real device on my network. Let's just start the capturing process, and hey presto, we can see that there. So I'm going to stop that now. And what you can see, I'll scroll down a little bit, but what you can see is rather exclusively we're only capturing packets from that particular device or going to that particular device. And in this case, you might be able to guess it's a Sonos device that is punching out probe requests on a very, very regular basis. And perhaps just to prove that I'm not cheating here and that's the only device on the network, I'm just going to remove that particular capture filter. There we go, and just start capturing again, and hey presto, we've got a pile of other stuff that appears in the window. So that's the essentials of using a capture filter. There's a variety of things that you can filter on: IP addresses, MAC addresses, and a whole host of other things. I haven't quite got space to put all of those different items in this particular presentation, but there's a reference in the presentation where you can find out about the syntax that you should use. Okay, so we're now going to have a look at a different type of filter. We're going to have a look at some display filters and look to see why we might want to apply a display filter and how we go about applying a display filter. So display filters are used to sift or filter what might be a huge collection of frames that you might have just captured. And in the example that I'm showing you here, I've got almost 18,000 frames that I have captured, and you can imagine the task would be to manually go through and select a small number of frames that you might be actually interested in. So using display filters allows you to quickly see the data that you're interested in. There's a very, very rich syntax for applying and using display filters, and it will be a chapter or two in a book to explain it in any detail. And there are lots and lots of references on the web which show you exactly how you do it in lots and lots of different circumstances. So here I'm going to take us through 5 simple examples of how we might apply display filters to extract some data, particularly at the wireless communications level rather than at the data frame level. So our first example I'm going to use is to show you how to select management frames only. So the first part of the display filter is WLAN, and then FC for frame control, and then type. That is the type of frame that I'm actually interested in. And in the first instance, I'm going to select type 0, which relates to management frames. So let's see what that reveals to us. And so you can see in the window that we have some probe responses and some beacon frames. And if I scroll down, we might see something else. There's an authentication frame down here. There's a probe request frame, and you're going to see huge numbers of beacon frames in this slot. Okay, so just scroll back up to the top. So there's our first example. A second example, I want to have a look at just control frames. So the filter is very similar. It's wlan.fc.type equals 1. So we'll just delete 0, put 1 in there. And in this particular case, what we're getting are control frames. So we're seeing clear to send, request to send, request to send, clear to send. We're seeing some block acknowledgements in there as well. But these are our control frames. We don't have as many control frames as we do have management frames. So let's delve a little bit more deeply into what we might see. So we can have a look at subtypes. So we'll type in subtype at this point, and you can see what's popped up as are a number of different subtypes that I can select that I've been playing with just recently. And the first one I'm going to have a look at is to see if we can get the request to send, to see if there are any requests to send, and that's subtype 27. And is it finding any? No, it's not. Okay, right, there are no request to sends in that, which is a little bit surprising. So let's try a different one. We'll try subtype 4, which is a probe request. And here are all the probe requests. There are lots and lots of probe requests in this particular capture, which is not surprising at all. Let's take a look at one other, which is a probe response, which is 5. And what we can see are loads and loads of probe responses. So between the subtype 4 and subtype 5, we can quickly take a look at the probe requests and the related probe responses. Okay, so we've seen a few examples of how we might apply display filters to select the data that we'd like to look at. And the numbers that I've been typing in against type and subtype, you might consider these to be magic numbers. They're easily available. Again, you just need to search for them on the internet. But I do have a few on the slides in this slide set as well, just to help you out. You've seen already some of the techniques that you can apply to display filters, and here's a table that's quite a useful reference table. It's only a partial table. There are fuller tables around that show you probably the most important types and subtypes. So using the syntax of text shown at the right hand side of the table, things like wlam.fc.type underscore subtype equals 1 will allow you to filter data showing only association responses. So you don't need to commit these to memory generally, but if you do remember that these filters are available, and tables like this are easily found on the internet. Let's take a look at an example of setting up a display filter to look for authentication processes. So what would our display filter string look like? Well, there are a number of things that we've got in this particular display string, and it illustrates a few underlying and important principles. So I've set the system, the display filter, such that it will display packets with a wireless LAN address equal to this particular address, logically ANDed with WLAN FC type underscore subtype equals 11, where the 11 is associated with the authenticate packet. So when we run this, what we'll see is a result on our screen where we will only show packets with this MAC address and packets that are authentication packets. And here we've got some examples of a display where we've got a device talking to another device where there's an authentication going on, but we're being selective with this particular MAC address. So it turns out that this MAC address here that I'm pointing to is the MAC address down here. It's just Wireshark has been clever and replacing the first few hex digits with the Samsung label, likewise with Cisco as well. The next phase in connecting a station with an access point is the association phase, and we're looking here at the association process, and we've got a couple of filters here that we're looking at using a similar syntax to the one we saw on the previous slide, where we're setting the WLAN address is equal to the LAN address of the device we're interested in. We're looking for the subtype equals 0 in the first case, which is an authentication request. In the second case, we're looking for a subtype equals 1, which is an authentication response. And the result that we've got from the data that we've collected is the authentication request from our Samsung device to the access point, and you can see there it's written authentication request. And the second response, when we've applied the second filter and removed the first, of course, is a frame that is coming from the access point going to the Samsung device and is the association response. So summarizing the slides that we've been looking at today, we first saw how to connect our Riverbed AirPcap NX interface to our PC and set that up so that we can capture data from that interface. We've seen some examples of how to design and deploy both capture and display filters, and then we saw some examples looking at both the authentication and association process. I hope this slide set's been useful for you, and thank you for watching.